antiderivatives include rearrangements into equivalent forms, such as long division and completing the square. All stuff you learned in prior units. In grade 12 pre-cal was long division, and grade 11 pre-cal was completing the square. So the first thing we're going to go over is long division. So has anybody come across an integral like this? Okay, so if the numerator is greater than or equal to the degree of the denominator, we do long division. So do you remember how that works? What goes inside, the top or the bottom?
Oh, the bottom?
Try again. This is the divisor, so this is what we're dividing by.
I said that, Mr. Ramsey.
Okay, how many times does minus 2x go into x? Try again. You have to make it. How many times does negative 2x go into x? Yes, negative a half. Thank you. So negative a half times negative 2x is positive x. Negative a half times positive 2 is minus 1. Then what do? We change the signs and we subtract. So what's negative 5 plus 1? Negative 4. So that's my remainder. And what do I do with my remainder? You put it over the divisor. So this is rewritten as the integral of negative a half minus 4 over negative 2x plus 2 dx. Okay, so I did say before, never try to integrate unless it's simplified first. Is there something we can simplify here? What? Yeah, you can reduce this whole second fraction by 2. Does everybody see that? Well, that's what I was going to do in my next step. I didn't want to do too many steps at once, so I will be doing that in a second. Actually, I'm not just going to take a half off. I'm going to take negative a half out. So anyways, so then I have negative a half. Does everybody see here? I'm going to factor out a 2, and I'm going to reduce it. So maybe I'm going to write this out because I'm going to lose somebody there. Does everybody see on this one, I can actually factor out a negative 2 and it's x minus 1? Yes. So does everybody see now the negative 4 on the minus 2 can be reduced to what? So a plus 2 over x minus 1, and that's dx. So actually, in the end, I don't end up taking a negative a half out, right? Okay, so what is the derivative with respect to x of negative a half? The antiderivative of negative a half with respect to x. I'm sorry? Negative 1/2 x. What's the antiderivative of 2 over x minus 1? So if you don't know this one, you would do a u substitution, and you would get, I'll do that just on the side. You don't actually need to do a u substitution. But what would u be? X minus 1. And what would du be then? Dx. So do you see what would this end up being? It would be 2 the integral of 1 over u du. So what do you get for that? What's the antiderivative of 1 over u? ln. So you're going to get plus 2 ln u, which is x minus 1 in absolute value, plus c. Again, the numerator degree is bigger than the bottom, so we're going to do a divide. So what goes on the divisor outside? Anytime, anytime. X plus 1, the bottom is the divisor, you guys. Okay, so do you remember what happens when we're missing degrees there, or exponents? What did we do? Do I just write it as x cubed plus x like that? So you can either leave a space or put a 0x squared. It's up to you. I like leaving a space personally. Okay? All right, how many times does x go into x cubed? Nope, that would be 3x. Try again. X squared. So x squared times x is x cubed. X squared times 1 is plus x squared. What do I do then? I switch the signs to subtract, and what am I left with? Negative x squared plus x. How many times does x go into negative x squared? Negative x. Again, negative x times x is negative x squared. Negative x times 1 is negative x. Then what happens? I switch the signs. These cancel, and what am I left with? 2x. There's nothing to bring down. So how many times does x go into 2x? 2 times. Again, 2 times x is 2x. 2 times 1 is plus 2. We subtract, switch the signs. These cancel, and I'm left with a minus 2 as my remainder. So what is this rewritten as? X squared minus x plus 2. And then what do I do with this remainder? Yeah, put minus 2 over x plus 1. This whole thing is respect to dx. So what's the antiderivative of x squared? 1/3 x cubed. What's the antiderivative of minus x? Minus 1/2 x squared. What's the antiderivative of 2? 2x. Now this one, hopefully you can picture what's going on. If not, you do u substitution. So what do you get? Very good. And then don't forget the plus c. There you go. So the division is a little trickier, but you got to just go with it, right? So I'm actually leaving lots of space here. Okay, x to the power 3 goes into x to the power 6, x to the power 3 times. So I get x to the power 6 plus 3x cubed. Then I subtract, switch the signs. These cancel. Now when you bring this down, if you bring this down, you have the 2x to the power 4 on the other side. And usually we do it in decreasing order. So we get a 2x to the power 4 minus 3x cubed. How many times does x cubed go into 2x to the power 4? 2x times, so then we get 2x to the power 4 plus 6x. Well, that doesn't subtract, so I'm going to actually move that a little over. Okay, so then I'm going to switch the signs. Switch the signs. I should do that in a different color here. Switch the signs. That cancels. Then I get minus 3x cubed plus 6x. So it's up to you what you want to do with. At this point, you could bring everything. Oh, something's wrong there, isn't it? This is plus 6x. This should be a minus, so this should be a minus. Let's try that again. So at this point, you can bring the remainder down, and you'll notice that the 6x's will cancel. Do you see that? So now, how many times does x cubed go into minus 3x cubed? Minus 3. So then I get minus 3x cubed minus 9. Switch the signs, and they all cancel, and I get 0 as a remainder. Very nice. So that means this is the same thing as x to the power 3 plus 2x minus 3 with respect to x. So I get 1/4 x to the power 4 plus x squared minus 3x plus c. All right. Good? So there is no coefficient of x squared here. So we're trying to get, now there is other inverse trig integrals. However, these are the common ones. Actually, inverse tan is the most common, and then inverse sine would be the next common, and then after that, they don't really ask too much. Okay? So completing the square, we have x squared minus 6x, then we scooch the 13 way over there. We're completing the square of that part. So what's the process? If there isn't a coefficient of x squared, you can go directly into the completing the square part, which is half the middle term minus 3 squared is plus 9. Yes? And I can't just add 9 without subtracting 9 right there. So then what does this become when we complete it? What, x minus 3. It has to be the same exact sign as what that middle term was. Plus, if I were to FOIL this out, I should get what that is, right? And then plus 13 minus 9 is plus 4. So this is in the form of 1 over x minus 3 squared plus 4 dx. Now notice if you memorize this, it's pretty straightforward. So I guess my recommendation is to memorize it. What is my h? Minus 3. What is my k? Nope. 2. Because this represents k squared, right? And this represents plus h, so that means this has to be a minus 3. Okay, so then you just put it in, bada bing, bada doom, plug her in and plug and chug, right? So we get 1/2 inverse tan of x minus 3 divided by 2 plus c. So again, this is a quadratic. Let's complete the square. So you have a 4x squared plus 48x, and then scooch over the 148. What's the first step in completing the square? Get rid of the 4. Well, you can't just get rid of it. You have to factor it out. Okay. Plus 148. Then we start the process. We take half of 12, which is 6. 6 squared is 36. 36 times 4 is 144. So what did I actually do here? I added 144. So what do I have to do to compensate? Subtract 144. So this is 4 bracket x plus 6 squared plus 4. Okay? So this is the integral of 1 over 4 bracket x plus 6 squared plus 4 dx. Now that's not what the form of inverse tan looks like. Inverse tan does not have that extra 4 there. Do you see? Inverse tan has, it's just x plus h squared. So what am I going to do then for this step? Take the 4 out. So what does that become when I take the 4 out? 1/4 integral of 1 over x plus 6 squared plus 1. I'm taking it out of both terms in the bottom, right? All right. So does everybody recognize? There's my h, there's my k, and my k, the square root of 1 is just 1, absolute value, right? Huh? Oh, sorry, dx. So what's my final answer? So don't forget the 1/4 here. So 1/4 inverse tan of x plus 6 divided by 1. And then you have a 1 over 1 there, which doesn't mean really much. So there's my final answer. So notice this doesn't look like an inverse tan one. So if you see a square root, just remember, oh, that might be an inverse sine. So we still complete the square. So negative x squared minus 14x minus 48. Okay, first step is what? Take out the negative. So then I have negative x squared, sorry, x squared plus 14x, leave a space, minus 48. So half of 14 is 7. 7 squared is 49, but really, what did I do? I subtracted 49, so that means I need to add 49. So this is negative x plus 7, the whole thing squared, plus 1. Now, this isn't a square root. Again, you need to memorize the form of this. The form is k squared minus the function squared. So we're going to write this as the integral of 1 over the square root of 1 minus x plus 7, the whole thing squared, dx. And remember that this is just inverse sine of x plus h over k. There's no extra 1 over k thing. Again, it's just a memorized thing. So inverse sine of x plus 7 plus c.